Okay, part 2, we're going to do the inverse cosine. So we're going to write it like that. The inverse cosine of some number is an angle. And again, we're used to saying the cosine of an angle is a given number, so we're going to reverse that. And for example, let's see if we can do the inverse cosine of square root of 3 over 2. So what angle has this as its cosine? So we're going to look up there and see the one I have written there is square root of 3 over 2. So that angle is pi over 6 when the first coordinate is the cosine. Is there another spot where that happens? Here we go, loop-de-loo. All right. So here we have, is there another place where the cosine is square root of 3 over 2? Well, I see this one is the one, the first coordinate, square root of 3 over 2. We already got pi over 6. No. Yes, here's the first coordinate, positive square root of 3 over 2. It's 11 pi over 6. So, what you going to do about that? All right, so we're going to have to mess with that to make sure that we don't have two answers for the same problem. So we don't want it to be 11 pi over 6 or, I forgot what it was now. It was 11 pi over 6 or pi over 6. So we don't want two answers for the same problem, so we're going to restrict the range for this one as well. This time, for cosine, we can't choose quadrant 1 and 4 because quadrant 4 has this in it, and we would have two answers. So we're going to pick quadrant 1 and quadrant 2 for arc cosine. So the only quadrants we can use are 1 and 2 for arc cosine. And we can write it like this, the y value is in between pi, we'll say 0, and pi radians. So that's the way we can indicate quadrants 1 and quadrants 2. The value's in between 0 and pi. So the range, the y value is in the first or second quadrant. All right, so I need some charting so we can figure out how to graph arc cosine. So we'll have the similar numbers. -1, negative square root of 3 over 2. Yep. Can you read these? -1, negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, 0, 1/2, square root of 2 over 2, square root of 3 over 2, and 1. This time, however, we're doing the arc cosine. So we will have a few good, even great people. That'd be Kevin, Bree, Ryan, and Shannon. So you're going to come up with these values from the unit circle. Like the first one, like one of these is done. What angle has the square root of 3 over 2 as its cosine? So the answer is pi over 6. So we've got one done for you. All right. The next and last is going to be tangent. So we're going to take the tangent of an angle normally and got a number, but now we're going to do the inverse tangent of a number to give us an angle. So just thinking backwards, and here is what that will look like. Say we have tangent of pi over 4. If you look on your unit circle, pi over 4 was right there. It was the middle guy and the middle guy. So tangent was the second coordinate divided by the first. So when you have this divided by this, square root of 2 over 2 divided by square root of 2 over 2, you're going to get a 1. So now we're going to reverse it and go tan inverse of 1 is pi over 4. So we're going to do it in the reverse order. So tan inverse, does it have an issue with different quadrants? So let's go over and see. Let's see if there's another spot that also has a tangent of pi over 4, a tangent of 1. Is there another spot that has a tangent of 1? So, ouch. So this time we need the other unit circle that's marked into quarters. Does it show up? Okay, this one, the smaller one right here. Is it showing up? I think it is. All right, so we found that this divided by this is 1, so the answer is pi over 4. So what about this one? 1 divided by 0, that does nothing, it's undefined. This divided by this is negative 1. I'm looking for a positive 1. This divided by that is 0. The second divided by the first, negative 1, is not what I'm looking for. Negative 1 divided by 0, undefined. Negative square root of 3 over 2. Oh, I messed up. This one back here, negative square root of 2 over 2. The second divided by negative square root of 2 over 2. That is equal to 1. So the signs were both negative, but when you divide, you get 1. So we found another spot, and that's 5 pi over 4. So coming back over here, we found out that we have another answer to the same problem. 5 pi over 4. However, we are going to have functions, so we want to restrict our range so that we do not get 2 answers, but that we get 1 answer. So in this case, for the tangent inverse, we're going to look in quadrant 1 and quadrant 4, just like for sine. So we're going to look here and here. And as you do more of these, you'll probably come to understand why we picked the quadrants that we did, but I'm not going to take time to explain that right now. So 1 and 4, sometimes we say negative pi over 2 is less than y, which is less than pi over 2. Or we can just say quadrants 1 and quadrants 4. These are saying the same information. So therefore, there's only one tangent, inverse tangent of 1, and that's pi over 4. All right, the group that will be graphing that is Black Hawk Up. We got Alex, Maggie, and Andrew. So on this one, we're going to change the values a little bit for inverse tangent. And it's going to look like this. We're going to have negative square root of 3. So here's your x values. And here's your tan inverse values. So you're going to do negative square root of 3. You're going to do negative 1. You're going to do negative square root of 3 over 3. 0. Square root of 3 over 3. 1. And square root of 3. I think there's a couple fewer than on the other groups. Okay, so you have these values to chart tonight and bring them with you. So you're looking on the unit circle and you're saying which of the angles has this as its tangent. So we've already done this one. 1 is right here. So what angle has the second coordinate divided by the first to give you 1? The only angle in the first and fourth quadrants to do that is pi over 4. All right. So if you would then come in with your charted values, and we will be graphing the inverse trig functions tomorrow. I'm sorry to leave you hanging there. I'm sure you'll have a poor night's sleep as you ponder these things, but don't worry, tomorrow we will show you the graphs and you can rest at ease. Till then, over and out.